Hello, good afternoon. I hope I am audible and my screen is shared. Okay. So in last lab session, we have created some programs related to loops. So today we are going to continue making programs for loops. Okay. In last lab session, we have discussed program for palindrome for checking if a number is an Armstrong number or not. Other programs we have discussed, right? So today we are going to discuss programs, more
Sir, am I
programs on
audible?
that.
Shri sir, am I audible?
So let me share the screen with you.
Shri sir, am I audible? Shri sir, am I audible?
Yeah. So here you can see a program with where we are discussing
Shri sir, am I
how
audible?
to print first n prime numbers. Okay. So this program we are going to develop to print first n prime numbers. So what are prime numbers? Prime numbers are numbers which are uh, not divisible, okay, by any number. Most importantly, the numbers are not even numbers. So 2 is the first and only prime number which is even. Except 2, there is no other even prime number. Okay. So here we have created a function. So you can see this is a function. So what is a function? Function is a derived data type, we can say, and a function is basically containing a return value. So you have created main function till now. So the return value of main function is integer. At times it is void. And here in main function, we don't provide any arguments. So, but normally in functions, we have got a return value, and in function, we can have arguments. So argument is the input to a function, right? And then we have got a function name. So here the name of the function is prime, and is prime returns a value which is of Boolean type. Okay. And inside this function, we pass a number as an argument. So this function takes an argument as a number and checks if it is Boolean or not. Sorry, and checks if it is prime or not. So being prime or not prime is a Boolean outcome. Means either the number is prime, means the value is true, or if the value is not prime, so then in that case the value is false. So if a number is divisible by any other number I, let's say there is a number num which we are trying to divide with a number as I, and when the this number I is perfectly divisible by I, the remainder is 0. So what you can say about this number? If the remainder is 0 upon dividing it with I, if the number gives a remainder 0, then the number is not a prime number. Okay. So we have to check for all the values, starting from 2. Okay, we will check all the
Shri sir,
values
am I audible?
starting from 2 to that number.
Shri sir, am I audible?
Okay, starting from 2 to that number,
Shri sir, am I audible?
right? So, for which we are going to test. So, till what value we are going to test? Till for the value which is less than I square. For a value which is less than or equal to I square. Okay. So if you want to check for 11, then in that case, you have to start with 2. Okay, you have to check with 3. So you will continue increasing this value till your I square is reached, till your I square is less than num. So first of all, you will check with 2. So now you compare, is 2 square 4 less than equal to 11? Is 4 less than equal to 11? Yes. So in that case, you will increment 2 with 3. Okay, I'll tell you the logic. So here we have got I square, and we have got our number. So let's say the number is 11. Okay, how is this function working now? This function has, let's say, taken a number as 11. So, and it has started with 2. So you will take 2 as I, and then the value of I square is 4. Okay. So you will have to check whether is the number being divisible by 2. No, it's not divisible by 2. And what is I square? I square is less than equal to 4. So here you will continue incrementing it. So 3. So for 3, you will have to check with the 11 by 3. Okay, so 11 by 3, it is not giving a remainder as 0. And 3 square is 9. Right? So 3 square is 9. Then you will check for 4. But for 4, the value of I square is the value of I square is what? 16. So 16 is greater than 11. So you don't have to increase that value. So you will just check with 2 and 3. So you will just check with for 2 and 3. There is no need of checking for higher numbers. Right? So it only checks for 2 and 3. If you give it a larger number, then it will compare the I square with that number. Okay. Clear? So it always check for whether a number is it completely divisible by I or not. So let's come to the main function. In the main function, what we are doing? In the main function, what we are doing? Okay, apologies for some disturbance in between. Let me share the screen again.
Sir, you are not still visible in camera.
So here,
Sir, am I audible?
we are trying to check for to divide with every other number
Sir, am
for
I
I
audible?
square is less than equal to num.
See, sir,
So
am I
for
audible?
all I squares less than equal to num, we are going to check on dividing that num by I. Okay, so what happens in main function? In main function, we are asking the number of primes to be displayed. Okay, how many primes you want to display? So the user enters some amount. Let's say I want to display first 10 primes. 10 primes I want to display. So we start counting with 0. Okay, and we start taking the number as 2. So the first 10 prime numbers we are going to print. So the first 10 prime numbers are what? So since the count is less than n, if the number is prime, we will print it. So the first number is prime. So 2 is prime. Okay, so we are going to divide 2 by 2 only. So we are going to divide. So we are going to print 2 first. Okay, so I is equal to 2. So if 2 is less than equal to 1, return false. No. So 2 is the first prime number, so it will print 2. Then it will check for 3. Okay, so it will check for 3. So 3 is not divisible by any other number. Okay, so it is also prime, right? So it will continue checking for other numbers like 4. So it will try testing dividing 4 by 2, 4 by 3. So 4 will go by 2, so 4 is not prime, right? Then it will check for 5. So it will try for 2. From 4 onwards, it will try. Likewise, it will check for all the values. So if the number turns out to be prime, it will print it. Right? This method is called a sieve of Eratosthenes. Okay. This method is called a sieve of Eratosthenes. Right. So this is a primality test basically. This method, we are checking for the range of values. So Harish sir is saying, Harish sir, actually there is some issue with camera. I have discussed with Dr. Saurabh Anand. So he has permitted me to continue with the session. I will later on verify what is wrong with camera.
It's okay, sir. You can continue.
I will rectify this issue with camera. Okay, but as of now, Dr. Saurabh has permitted me to continue with the session. Very well. Okay. So let's demonstrate this program here in the code blocks. So I hope code block screen is shared with you. Okay, so new file. So we can take experiment 6. Dot C. So let's develop this program. So here we can use the Boolean function, the Boolean data type. Okay, so we can have a function, or we can directly start with the main function, int main. So here in the main function, we are going to declare a variable, let's say n, and then we are asking the user to enter how many primes you want to display. Enter the number of primes to be displayed. We'll scanf this value as an integer value. And so now we are going to check for count. Okay, here also you can display count because we have to keep a track of how many numbers we have printed. So count I have initialized to 0. Okay, so we will print first the first n prime numbers are. So here we'll put n. So while, so now we have to check for the count not exceeding n. If the count is less than n, then what we will do, we'll call our is prime function. So if is prime, so we will have to create a function called is prime, in which we have to pass a number. That number we have to initialize at 2 as 2. So number is the first prime number is 2. So num, if the number is prime num, then we will print it, of course. So then we will print that number. Printf %d, put a space after that, and then print our number here. Okay. And then at the same time, we will increment our counter by 1. And then we will have also to increment the number by 1. So number will also be incremented and count will also be incremented. So every time we are going to increment the number for testing, because we have to do a divisibility test. So this divisibility test will be done outside basically. Here we will do return 0. So now the question is, what will this is prime function do? So we have to declare a function called is prime, which returns a Boolean value is prime. So this is prime will take an integer argument, let's say num. Okay. So now what we will do with this number, we will check whether it is 1. If num is less than equal to 1, we return false. Then for we have to test it by dividing. For int counter is equal to 2, then I square is less than equal to num I plus plus. Okay. Then what we will do in this, we will check if the number after dividing with I returns a 0. So if it is completely divisible, we will return true. And if you come out of this loop, we will return true. Okay. You will only return false when number is less than 1. That is our primality testing number. Primality testing function will do. Testing function. Okay. So here, let's try to execute this code. Okay, so we have to declare this function at the top. So what we can do is we can declare this function at the top at global declaration section. We can declare this function. Okay. Or we can shift this declaration before the main function. That also is one option. Okay, this is not able to recognize this bool. So for this, we have to include another file. It is called std bool. So this header file we will include here. So then it will work perhaps. Okay. So you try it at your end, see if it is working. Students are saying my voice is not audible. Is that the case? Are you not able to hear my voice? Yogesh has said that my voice is not audible. Is it the case? Please acknowledge if my voice is audible or not. Students are mentioning my voice is not audible.
Audible, sir.
Okay, good. Great. Okay. So please try executing this code, see if it is working at your end. Yeah, no voice. I don't think uh, that should not be the case. I have put the code on the screen and you are supposed to try it. I was not speaking for uh, some seconds, so that is why you were thinking like that. So please try this code at your end, see if it is working. Yes, who has tried this code? I have already sent the code to you above. Scroll up in the chat, you can find the code. Again, you want me to send? Okay. Try this code at your end, see if it is working. Okay. There is a bracket mismatch. That's why some students were not able to run the code. I will repaste the code again. Okay, I will share the screen at my end. See, can you see the output screen? So here it is asking me to enter the number of primes to be displayed. So let's say I put 5 here. So it is giving uh, 2, 3, 4, 5, 6. Okay. So it is checking some condition for which it is verifying whether it is true or not. Okay. Okay, it is working for some students. Okay, so this is the code that we have executed. All right. So let's come to the next code. So some students were able to execute the code. So there are other programs where you can display the next nearest prime number of a given integer. Okay, so here we have created another code similar to the previous one where we are displaying the next nearest prime number for a given integer number. Okay, so let's say for example, the nearest prime number for 5 is 7, for 8 it is 11, for 7 it is 11, right? So here we are going to take a separate approach. So in that case, we take a Boolean variable and initialize it to false. Okay, until that the variable not equals to 0, we increment n by 1. Okay, and check whether it is prime or not. So until that the variable is not equal to 0, we continuously increment n by 1 and check whether it is prime or not. So we start with any number. So let's say for 5 we start. Okay, then for 5 we go for 6. So 6 is not prime. So 7 we check, 7 is prime. Likewise for 8 we check with 9, 9 is not prime. For 10, 10 is not prime. So 11, 11 is prime. So we print 11. Likewise. So our counter starts from the given number, basically. Okay, so it is not about matter of how many prime numbers we want to print. It is the question is changed. In this case, we are going to print the next nearest prime number. So if it is prime, then we will print it. Okay, otherwise we will have to keep on iterating the loop until we get a prime number after due to iteration. So for every iteration, we have to check whether the new iteration is a prime number or not, right? So this is the logic. So in that case, we have to check for this is prime. Okay. So here, let's first of all understand this main function. So inside main function, we are asking the user to enter an integer. So let's say the integer entered is num. And then what we are doing is we are declaring another integer as next prime, which we are assigning as the return value of our function next nearest prime. So in next nearest prime, we are passing the number as an argument. So the function call takes us from the main function to this next nearest prime function. In this function, we have passed number num as an argument. So let's say the user has passed 5. So we will check if 5 is less than equal to 1, we will return true. It means that for all values less than or equal to 1, the nearest prime number is 2. So it is a static value. Okay, if it is not 1, if the entered number is not 1, we will execute the do loop. So first we check if the number entered is prime, is num. So we will return that number, and then this 5, this num is passed in this. So now the value is 5 here. So we check for if 5 is less than equal to 2 or 5 is divisible by 2, which is not the case. So 5 is not less than 2, less than equal to 2, and neither 5 is completely divisible by 2. So this if block will not be executed. Now, what we are going to do for 5 is that we will start with 3 because 2 is not an option. So we start with 3 and then we continue for the value 3 less than equal to n by I. So first you check whether the n by I means what. So 5 divided by 3. So number is 1. So is 3 less than 1? So this option is not going to work. So what we are going to do in that case, we have to increment the number by 2. Okay, so we will check for 5 by 5, right? So likewise, we will identify the next number for which the value comes out to be prime. So this logic is same, I less than equal to n by I. Okay, so this logic is same and we are going to return that number which is the nearest number as this value. Okay, so it will return this value. So it will return the number and then we are going to increment this number, make num as 6. Okay, so this we are going to do till we get the nearest prime number. Okay, so it will return a number as the nearest prime. So let's run this example. Let me open the code blocks. So we are going to keep this is prime function nearly same. So it is going to return an integer value actually. So this integer is prime logic is same. Then we also need a function called next nearest prime. So int next nearest prime. This function we need, in which we are going to pass a number. Okay, so this function we are going to need, and in the main function we are going to declare a number. So here int num printf enter an integer. Okay, scanf that number. Then int next prime. Now the value returned by the next nearest prime we are going to print here. Next nearest prime, and we pass our number here. So we'll print next nearest prime is %d next prime, return 0. Now in next nearest prime, what we are going to do? We'll check if number is less than equal to 1. If that is the case, we will return 2 as an answer. But if that is not the case, we will execute our do block. In this do block, we will call our is prime function. Okay. So is prime function num. We'll pass this argument as num. In this, we will return the number. Okay. And then increment num plus plus. So this we are going till we find a prime number, because this is an infinite loop. So that is why I am writing here while true. Now in is prime function, what we are going to do is we are going to check for if n is less than equal to 2 or n mod 2 means n is divisible by 2 equal to 0. If that is the case, then we are going to return n as 2. If that is not the case, so then we are going to run a loop from 3 onwards till I is less than equal to n by I, means the quotient of the division n by I. And then we are going to increment the step by 2. Why? Because we are going to skip all the even numbers. Okay, even numbers cannot be prime. So for due to this, we are going to skip all the even numbers from being checked for primality, because even numbers except 2 cannot be prime. So we are going to divide. If you come across such a number, we will come out of the loop. Return 0 for that particular number. It cannot be a prime number. So if it is an odd and if it is not a prime, we will return 0. So we'll continue checking till we meet a prime number. But if it is a prime number, we will return 1. So if it returns 1, it returns true. If it returns 2, we return the number. If we return the number, we print the number. That's how it works. Okay. So here there are two functions running parallelly, or calling each other, I should say. So let's try this code here. Okay. So if you see this code, you can see that I have entered 6 and the next nearest prime number is 7. Okay, for any integer which is prime, the nearest prime is itself. So better try not to check with the next prime for a prime number. It won't work. because logic is so made. Always try for a non-prime number nearest value, nearest prime for a non-prime number. So you can check for 13, or you can check for 14, 15, 16, all these numbers, it will come to be 17. Okay. Let me run the code again for other values of n. So I will give this code to you for trying. Try this code at your end, see if it is working. See this code is, it is working. You could have also taken screenshot for the previous code to see if it is working. Error should not be there. Read the error. Put the error on the chat. Let me see what is the error. You must have forgotten some import statement or something. Put the error on the chat. What error are you getting? Yes, Uday. Paste the error on the chat. I hope you understand what I'm saying. Put the error on the chat. It works. Bhumin has tried. It is working. Okay. Check for values like 14, 15, 16. It should work. Yes. Who else has tried except Bhumin? Uday has tried but getting error. I'm asking Uday to put error on the chat so that I can fix it. What about other students? Rahul, Jayant, Ria. Are you people trying this code? Okay. So moving on, one fun program is there to print a right half pyramid. It's a pattern printing program. So this also takes loop into account. So here what we are doing is we are printing a right half pyramid. You can have other pattern printing programs here. So it is asking I, J. It is taking two counter variables and also taking rows into account. Okay, rows into account. So it is asking the number of rows. Yes, n is equal to, yes. Two equal twos have to be put. You cannot have assignment in return statement. You have to have an evaluation condition, relational expression. So n is equal to 2 should be the condition. That's right. Okay. So here it is asking me, I have to provide how many rows I have to print. So let's say I want to print 5 rows. So I will start from the first row. So if my I value is 1, see, I am maintaining a uh, dry run table here. So number of rows is 5. So in the first row, is 1 less than 5? Yes. So if 1 is less than 5, what I have to do? I have to start from 1 and print as many stars as I value. So in the first row, I have to print only one asterisk because I have started from 1. J is also 1. So J can reach up to 1 only. So 1 is less than equal to 1. So it will print one asterisk. Now, what will happen? You will come out of the loop because after that J will become 2 and 1 is not less than equal to 2. So due to this reason, you will come out of the loop. Now what will happen? You will increment I. So I will become 2. Again, J will start from 1 because it is a nested for loop. So J will become 1. So it will print one asterisk here. And then J will again become 2. Why J is incrementing? Because J has to reach up to I. So as soon as J and I become same, it will come out of the loop. Then again 3. Again you will start from 1. Will print one asterisk. Then you will have 2. You will have second asterisk. And 3. 3 has meets to 3. So this has been printed here. So likewise it is go till 5. So this will value till go till 5 and print this pyramid like structure. With this right angle triangle it will print with asterisks. Okay. So let's try this code here. Okay, so this is pattern printing program. You can try for different patterns here. Patterns like this. You can try equilateral triangle type pattern or inverted triangle like pattern. This pattern also you can try. Okay, other patterns like Pascal's triangle are there. So it is 1 1 1 1 1 2 1 1 3 3 1. Like this you can print. Or you can have character pyramids like A, B, B, C, 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 D, D, D. Like all these patterns you can print. Try out. But for now we are printing this right angle triangle. So here include. So here we have to declare int I, j, rows. So we'll ask the user to enter the number of rows, enter number of rows. Scanf %d rows. Now we are going to start with I. I is equal to, so I will start from 1. I less than equal to rows and you do I plus plus or plus plus I. In this, we have a nested loop for j. J is equal to 1. J less than equal to I because the inner loop will run till the maximum value of I, till the value of I. So in that case, what you will do is you will print an asterisk with the space. Okay. And then as soon as the inner loop terminates, you will print a new line character to change the row. Okay. Right. So with this, we will print a right angle pyramid. So let me run this code. Okay. So I was able to print this. I will put the code on your chat. See if it is working at your end. Did you try this code? See if it is working. Did anyone try this? It's working. Okay. What about others? Did you try? If you want, you can also do some changes. So you can do an inverted pyramid, like in for I is equal to rows, I greater than equal to 1. Try this. See what pattern it prints. And then decrement this value. So made a couple of changes here. Try this combination. So if you try this code, you can get this pattern like this. See. So it starts with number of rows and then continues to decrease the number of asterisks in the till the end. Okay. So just this for loop you have to change. So you can change the pattern. So this is an example of a nested loop which we have seen. What about others? Did you try this new line of code, this new pattern? Okay. Okay. So many students have tried it. Similarly, you can try for left half pyramid, right half pyramid, other variants you can try out. Okay. For bigger triangles, you can have to take into account the number of spaces in between. Okay. So no, I plus plus actually it is pre-increment and post-increment. So at times you might need for pre-increment means you decrement before and then you start with a new value of I. So it's like this, or you take the recent value of I and then decrement it in the upcoming iteration. So depends upon your requirement basically. Okay, we need to what we require. So here we will decrement it and then continue with the decremented value in the loop. So that's why we will do a pre-increment. Okay, so that's all for today's session. Thank you very much for attending. Happy learning. This is the last lab session. Okay.